What do I understand? What do we understand by the term called semi-deterministic? There is, in semi-deterministic models, we have a formula. The formula is not given here. We have a formula, but we are not sure about its coefficients, right? Let us see one example. For example, I have a formula, standard microcell model called K1 plus K2 log D plus K3 something. So there is a formula, but these coefficients of the formulas, are not fixed. And they can be tuned, right? So that is what we mean. But overall, as per 3GPP, these are the propagation models which could be used for 5G. Okay, then we have the thing called penetration losses, right? So every type of loss, penetration losses are depending upon the frequencies that you're using. Higher the frequencies, higher will be the losses or the margins that you are going to consider, right? Then for certain materials, 3GPP has defined how much is going to be their losses. So if you're using a glass panel, so that should be equal to 2 plus 0.2 of frequency, which are given in gigahertz. This is important. Frequencies are in gigahertz here. So if you're using an infrared glass, IRR glasses, so their losses are a little higher. If you're using concrete, their losses are like this. Okay. Concrete is dependent upon the factor for the frequency is really strong in concrete 4. So as soon as the frequencies become higher and higher, the losses will also become higher and higher. Okay, and these are some, industry specific examples of how much loss are going to be there in which cases. Then we have slow fading margin. Okay, let me explain you what exactly is the meaning of slow fading margin. So this is signal strength. This is the distance. So when distance between what? Distance between the G node B and the mobile phone. When this distance keeps on increasing, the signal strength goes down, right? This process is called as slow fading. Then we have another type of fading called fast fading. I am sure you may have heard of one thing called relay fading effect, right? My spellings are not good, so I'm going to say relay fading, R fading. So what does R fading says? That at this point of time, if you are expecting a good signal, you can get even better. If you are expecting a bad signal, you can get good signal. So this is how the fast fading works, right? So you are expecting a bad signal, but you're getting a good signal. You are expecting a good signal, but you're getting a bad signal, right? This change happens very fast, and that is why it is called as fast fading. Reasons could be so many: buildings, vegetations, etc., etc. So that is something which we can't determine and put them as a margin. That is very, very, fast changing, and that is why we need to perform model tuning and we perform simulation as well, right? Only because of fast fading. But slow fading is, or the shadow fading is easier to understand. Slow fading and shadow fading are same. So you can simply add them as a margin, right? So whatever is the coverage that is coming, you can reduce that coverage 4 dBs in case of LOS and 8 dBs in case of non-LOS if you're using a rural macro model. If you're using an urban macro model, 4 and 6. If you're using street canines in the urban micro, so 4 and 7.82. If you're using in building or in office, it will be 3 and 8.03. Right? These are some industry standard fading margin values which you can consider in your network. Then we need to identify the scenarios. Slow fading standard deviation, you consider 4 dBs, slow fading margin is 4.16. For a LOS coverage area probability of 95% and the cell edge probability as 85.1%. This is what is the margins that we need to consider. For non-LOS, these are the margins that we need to consider. Some important differences between the LT and the 5G in terms of the link budget is that the foliage loss becomes a very subsequent point of consideration, because in 5G we have higher frequencies and higher frequencies are tend to lose very easily even with the foliage and vegetations. And how much consideration we need to keep in that case are given here. The expected consideration or industry standard which are used, and the typical value that is considered is 8 dB. If the tree is a not very dense tree, if the tree is a dense tree, in that case the margins are going to be 15, and a typical value you will use it between 16 at the crown to 11 at the lower part. Okay. If you are having two trees, dense both of them, if you are having three trees, this is how it could keep. As an industry standard, as of now currently, we are keeping 17 to 20 dB as a standard for the foliage losses or foliage margin, you can say. Okay. Now let's have a look at the comparison between the 4G link budget and the 5G link budget. So here, one of the important thing is the base station types or the RBS. So in 4G, they were majorly remote radio units. That means you have antenna, and antenna is connected with the feeder through a RRU. So the feeder will have the feeder loss also. And in between where, so this feeder is actually a jumper, sorry. There will be jumper loss also, which is a higher losses, right? In 5G, we use the active antenna systems, which is nothing but an antenna and the RRH, both are combined together, right? And then it becomes an advanced or active antenna units, right? So they don't have any feeder loss, jumper loss, cable loss, etc. And they are high performance. So this is one of the difference. Here you are using majorly 1800. In 5G currently 3500 spectrum is very widely used, right? Bandwidth in LT are somewhere around 10-20 megahertz. Here it is starting itself with most of the vendors there, most of the operators, they're starting with 800. Maximum powers are kind of same. PA powers are also same. Antenna gains are different. Antenna gains in 5G is too high. In LT it is going to be 17.5. Here it is 24.1. For the interview purpose, these values need to be very, very clear. So all those who are using this training as a tool In order to crack your interviews, please make sure that these values, you keep them by heart while performing or sitting in the interview. So this is very important. Propagation models are ray tracing models for indoor majorly, right? Ray tracing models are dependent on the 3D modeling, etc. So building penetration losses we are not considering because we are making use of buildings in the form of the actual map information, which is going to be used in creating the simulation. So 3D maps are become very popular, which is what is used there. So that was it for chapter 2. I will see you in the next chapter. Thank you so much.